When it comes to the logistics, earliest stage of human civilization was backbreaking. But over a course of time, the stupendous invention of the wheel came into the picture. It has a great evolution from stone wheel to the recent air-filled rubber tube wheel. Here it is. Hey, what's the shape of the wheel? Wow, it's a circle, isn't it? You know, circle is a collection of all points in a plane which are at constant distance from the fixed point. Correct? Yes. Come, let's see what's happening in the field. Oh, the little boy is drawing a circle using a fixed point and the fixed distance. Both are very important in drawing a circle. The thread length being the same, the distance of any point on the circle from its center is perfectly the same. Hey, look here. The two kids are standing on the circle at two different positions. They are the points A and B as shown in the figure. The stick represents a line in the picture and AB represents the line segment called the chord. But the entire line is called secant. Secant is derived from the Latin word secare, which means to cut. The straight line that slices the curved line is called secant. See here, this is the secant for this curved line. Coming back to the field again, see they are standing at different positions on the circle, forming a secant every time. Wow! One can draw any number of secants as there are infinite number of points on a circle. Now let's talk about another situation where the line is meeting the circle at exactly one point. Yes, it is touching. The line that meets the circle at one point is called tangent. Tangent is again derived from the Latin word tangiere, meaning to touch. This point where the line is touching this circle is called point of tangency or the point of contact. See here, this is the tangent for this curved line at the point highlighted. So just remember, secant means to cut, tangent means to touch. In this circle, Mn is the tangent and Rs is the secant. Let's see something interesting. The two kids are coming closer and closer. We can see here the 2 points A and B are coming closer. That is, the chord AB is becoming smaller and smaller. Yes, means to say no more chord. And no 2 points A and B. Both the points are coincided. It's a single point now. And let's represent it as P. But the line AB exists still, and this is a tangent as it is touching the circle. With this, we can conclude that tangent to a circle is a special case of the secant where the two endpoints of its corresponding chord coincides. Look here, one kid is standing at a point and rotating the stick in all directions. You see that at a fixed point on the circle, there exists only one tangent, and rest all the possibilities are forming secants, meaning the lines are cutting the circle. Alright? Let's try this at some other point. Wow! Only one tangent again. So we can conclude that there cannot be more than one tangent at a point on the circle. Let's use the tire now. The tire of the wheel is touching the table, that is, circle is touching the line. We can say this is the point of tangency or the point of contact. Before I move further, have you ever wondered why the wheels are circular in shape and only in circular shape? Why not the shape of a square, triangle, so on and so forth? I know what you are thinking. It's going to be a bumpy ride, right? Okay, there's something more significant than this. Let's explore it together. What do we see here? Rail wheel, right? If we consider the rail wheel as a circle, the rail track can be considered as the tangent. The area of contact between the wheel and the track is very minimum and hence exists minimum friction between them. You see the shape here? This is to have minimum area of contact. Lesser the area of contact, lesser the friction. Thus, if wheels were of any other shape, it would have had more area of contact, thus more friction. You know that the rolling friction offered by the rail wheel is 1000 times lesser than the rolling friction offered by the car wheel. What? Is that so? Then why rubber tires are used for the cars? Instead, we could have steel wheels just like the rail wheel? Because certain friction is essential for us to avoid skidding while we turn around, quickly accelerate or slow down. Oh, fairly correct. Now we can relate why it takes longer time for the running train to slow down and to stop. Whenever you are free, think of the reason behind the wheel size and shapes of these vehicles.